So think of off with your head when you look at elimination reactions. In this objective, we'll apply reactivity principles to elimination reactions. Note that the structural features include an alpha carbon, an H on a beta carbon, and a leaving group. In an elimination reaction, the reactants are the same as in the substitution reaction. However, in an elimination reaction, note that an alkene forms. In an elimination reaction, we need a leaving group, a H on a beta carbon, and a nucleophile. A pi bond forms to make an alkene. An elimination reaction is a good way to make a pi bond. Note that an H on the beta carbon and the leaving group are eliminated to make that pi bond. So in the elimination reaction, a nucleophile reacts at the H on the beta carbon, which is an electrophile, and the leaving group leaves. Now that you've identified the structural features, let's use curved arrows to show which bonds break and which bonds form. So stop the video and answer these questions. So here are the answers. And the curved arrow is to form a pi bond. So let's practice. Stop the video and use curved arrows to show how each reactant forms that alkene product. So here are the answers. First, identify the structural features. And here are the curved arrows. In the reaction on the right, note that OH is a poor leaving group, so H2SO4 makes it into a better leaving group. Once the OH turns into a better leaving group, HSO4- or H2O behaves like a nucleophile and reacts at the H bond to the beta carbon. Note that the reactants for an elimination reaction are the same as for a substitution reaction. The only difference is that for an elimination reaction, we need an H bond to a beta carbon. The only difference between a substitution and elimination reaction is where the nucleophile reacts, either at the alpha carbon in the substitution reaction or on the H bond to beta carbon in the elimination reaction. The two types of elimination mechanisms are E1 and E2. So stop the video and use curved arrows to show how bonds break and form in each mechanism. So here are the answers. In the E1 mechanism, the leaving group leaves first to form a carbocation. Then the nucleophile reacts at the H bonded to the beta carbon. In the E2 mechanism, the nucleophile reacts at the H bond beta carbon, and then the leaving group leaves. Remember that the 1 and the 2 refer to the overall order in the rate law for the experiment. Alcohols also undergo elimination by an E1 or E2 mechanism. So stop the video and use curved arrows to show how bonds break and form in each mechanism. So here is the answers. The only difference is that the alcohol group needs to be converted into a better leaving group first before the elimination reaction can occur. In the E1 or SN1 mechanisms, a carbocation intermediate forms. When you see a carbocation, check these three things. So let's check your understanding of the E1 and E2 mechanisms. Read the information on this slide, stop the video and answer these two questions. And the answers are? So let's practice an elimination reaction. Stop the video and predict the product of this reaction. Before we review the answer, let's consider these questions. And here are the answers. Two possible products form depending on which H on which beta carbon reacts with the nucleophile. The more stable product is this one. The more substitute the alkene, the more stable. Let's practice an elimination reaction involving an alcohol. Stop the video and describe the reaction mechanism and explain the product distribution. So here's the answer. In the first step, a better leaving group forms. Note that there's 3 beta carbons. So a nucleophile will use water, reacts at either H bonded to either beta carbon. The more substituted alkene is the major product because it's more stable. Here we're given an alkene, which is the product of an elimination reaction. To synthesize each compound, which reactant would you use? To make compound A, we need a reactant with a leaving group, an H bond to a beta carbon, and a nucleophile. So here's a possible reactant. And here's how the nucleophile would react with it. So stop the video and you can do B and C. Here are the answers. Remember that the alkene forms between the alpha carbon and beta carbon. Why do you think the compound on the left is a better reactant than the one on the right? For compound C, one possible reactant is shown. Tertiary amines are used in many applications, such as precursors to photostabilizers and polymerization inhibitors, and as reagents in catalysis. Some of these larger tertiary amines are hard to make because they undergo elimination reactions. So stop the video and use curved arrows to show how a tritert-butylamine undergoes this elimination reaction. First, here are the structural features in tritert-butylamine, and here's how the reaction occurs.